Hi ladies and gentlemen, this is me, Makalasi, and today I just want to go ahead and talk a little bit more about the fourth dimension, because a lot of times when I hear a lot of the people talking about the fourth dimension, and some people are even going as far as saying we're in the fifth dimension now and things of that perspective. And I thought it would be a really good idea to show you how we really are actually in the third dimension, just to go ahead and ground us. But at the same time, realize that from the fourth dimension, things are going to be, the perception of reality would be a lot different from our perception that is now. And if you're basically looking at things from a third dimensional perspective, life would be basically the same. Where when you're looking at things from a fourth dimensional perception, and you're looking down at something that's third dimension, or before you actually get in the third dimension, there is a big difference between the third and the fourth dimension, as well as that there would be something a little bit different from the third and fifth dimension, just as there would be a difference from the first and the second dimension. So just go ahead to just start off real quick. So here I have, this is a point. It's a point is a 0 dimensions. It's a 0 dimension topical space. It's topical space that has 0 dimensions. It's just a dot. So when you're thinking of a dot, this is basically nothing. It's just a point of reference. So what happens is when you start to have one dimension, what you do is you take 2 points. So if you look at, there's one black point on the left, and then there's a black point on the right, and there's a red line connecting 2 points. So when you connect those 2 points together, you're adding length. And that is basically one dimension. So I have here one dimension connects 2 0 points together. From the 0 points perspective, this would seem like an amazing concept, being able to connect 2 points at the same time. So what happens is, when the 2 points, like some of that can go from like one line to another line, that's like kind of like going parallel to a point, and it would be like a miraculous thing from the 0 point perspective. How did you move from one point to one point? I didn't even know there was a different point. I didn't know that there was length. So that would be like a new trailblazing idea to a 0 point. So when you have length that acts like a dimension, so I have here like there's an arrow going to the right, and I have underneath it one dimension means something has a length, but no width or height. A one-dimensional object has no thickness at all, only length. So realizing like basically there's no thickness, there's no nothing, it's just a concept of length. So to go ahead, before we go ahead and explain the second dimension, I'm gonna put here and show you guys. Now I'm gonna just take the same concept I had here with the one dimension, and I'm just gonna make it parallel to each other. So now I have a dimension going from the top, and a one dimension going on the bottom. Now, but these are basically 2 one dimensions, and I have here on the bottom, these are 2 one dimensions who are parallel to each other and are unaware of each other. They both have length and nothing else. However, on the second dimension, we can connect them via height, adding width and height. So now we have 2 points. So basically, on the one, you have 1 point can go to the second point through a line, and you have a parallel that doesn't even know about each other that can go from 1 point to 1 point, and that's all they know, and it's just a line. But when you have the second dimension, now you're adding a square, and what happens is on the second dimension you can add those 2 1 points together. So I have here on the second dimension has height and length connecting the 4 points. The two dimensions are commonly called length and width. Both directions lie in the same plane. So here I have the 2 one dimensions that are red on top, one on bottom. And now what happens is with the 2 dimension, I can go ahead and connect it with the blue arrow. Now, if there was only someone that was one dimensional, and the 2-dimensional person was able to jump from their dimension to the second, one dimension, and then jump to the second dimension, which is parallel. The one-dimensional person that only understands length would not understand the concept of height, because they're just like, I just know point A to point B. How did you jump? And then the second-dimensional person say, oh, well, what that is called height. But what would happen is they would understand that. So here I have a better example. So basically when you look at the second dimension, you're looking at length and height. Now, like I was saying, the first row, which is red, and the on the top, and there's a row on the bottom, those are both one-dimensional concepts. So they wouldn't understand how you can go from one dimension to the other dimension through height, because they only understand length. But on the second dimension perception, you can understand connecting those two through height. So then you have length and height. So commonly, when you're thinking of a one dimension, you're just thinking of a line. When you're thinking of 0 point, you're just thinking of a point. And when you're thinking of a second dimension, you're thinking of length and height. Therefore, when a lot of times people think of a second dimension, they're primarily thinking of something like a piece of paper. So when you look at something on a piece of paper, that's something like a second dimension. So let's just say I drew a person on a second dimension paper, or one piece of paper, and then that's basically all the person experiences is like that paper. So on the third dimension, we can have like maybe 3 or 4 pieces of paper, which is like 3 or 4 two-dimensional aspects of drawings, and the piece of paper concept wouldn't really understand that. So then we're going to go into the third dimension. But before I go with that, I'm going to go ahead and read this. It says the dotted lines. The dotted blue lines is a representation of height, which the second dimension is connecting the two one dimensions length. But when you look at it all together, you know, we're not going to look at two one dimensions together. All together, it's called two dimensions. So this is basically how a two-dimensional concept looks like. It looks like just like a square. And they don't have what you would call the third dimension width, so every to them is two-dimensional. So like a drawing, a cartoon, even this drawing right here is just two-dimensional. So here I have two-dimensional squares, and let's just say they don't really know about each other, and if I was to add width to it, because width is third dimension, then you can see like the two pieces of paper which are red, or the two dimensions, now have width. So usually, you know, from a third dimensional perception, which we're at, and when you see a piece of paper even is an analogy I use, but even a piece of paper has width to it. If you hold it to the side, you can see that there's width to it. So technically, a piece of paper is three-dimensional, but the concept of analogy, I just like to use a piece of paper for, like, if you draw a stick person, that stick person would be more like a two-dimensional concept. Now, if you're going to measure the width of the ink, then you can still say technically in a minute level it's third dimensional, but you get the idea. So when we're dealing with one dimensions, we're thinking of a line. When we're thinking of two dimensions, we're thinking of a square. And then when we're thinking of a third dimension, we're thinking more length, one dimension, height and width, which is two dimension, length, height, and width is third dimension. So here, when you get into the third dimension, you're more thinking about a cube, something that looks like a cube. So I have here, now you can connect the two dimensions, height and width, by adding width. From the two-dimensional perspective, they would not be able to comprehend the concept of attaching two separate dimensions via width. But on the third dimension, we can see it. So what happens is, when you're dealing with things that are on the third dimension, it looks like this. There's two widths, and then basically there's different sides. But I like this picture better because this shows you on like you know, when you look at the dotted lines, that's us saying hypothetically we can look behind the cube. But technically, we can't really see through a cube. So when we're looking at a cube, the solid line is basically something that's visible to our naked eye. This dotted lines right here in the back is basically saying if we could hypothetically look through the cube, we can see those dotted lines. But technically, when you're thinking of a third dimension, it looks like this. There's cubes, and basically all we can see is the three corners. Is three dimensionals. We can kind of estimate the width, the height, the length of it. Now, if we have something to compare it to, we can compare it through observation, the height and width of it, to maybe like something like a marble or something like a dice. You can see if it's a big cube or a small cube. But basically, in the third dimensions, we can kind of see things from width, height, and depth. So now let's go on to the fourth dimension. So with the fourth dimension, what you're doing is you're taking something like these two cubes, and then you're going to have to put them together. Because if you're realizing what's happening is you're taking like the old, it kind of builds up on the old dimension. So you'll take one dimension, which is 1. You'll take a dot, which is 0 point, and then you take two dots, line it up, that's 1 dimension, right? And you take 2 1 dimensions, line them up, then that will be 2 dimensions. And then you take 2 dimensions, line them up, and then that would be 3 dimensions. If you see my thought, that's what we're doing. So what happens is with the fourth dimension, you have to take 2 cubes, line them up, and then add the corners, and then that makes a fourth dimension. So if we were to take these 2 cubes now, put them together, and then line them up, you would get something that looks like this. So here on the left, to make it easier for you, I have here a red cube in the front, and I put a blue cube in the back, and I put the green lines to show you where they're connecting. And this is basically the concept of the fourth dimension, which people have said is a concept of time. And I'll go ahead and illustrate that. So basically, when you have 2 parallel cubes from the third dimension connected together, and then you have, and then there's a connection to those 2 cubes, then you have the hypercube, or what you can call the fourth dimension. So if you look at this picture I have here, you know, I have the concept of height, width, length, which is the third dimension, and then I went ahead and include the yellow arrow, which means time. So basically, when you're thinking about it, on the fourth dimension, you know, they kind of see the connection between the past, the present moment, and the future. So everything kind of happens simultaneously. Now, from our perspective, that's kind of hard to understand because we live in the moment. We live in the moment, and that is what we experience. And even though we are kind of going through the transition of time, as we are going through the transition of time, we're experiencing it. So in essence, in the fourth dimension, we are kind of like something on a movie reel. So here's some boxes, and this is us. We're supposed to be cubes. So what happens is we experience one moment at a time. We only experience the moment. We really don't understand the past, and we really don't understand the future. We only are technically in the moment. But from a fourth dimensional perception, they would see us, like let's just say this was me right here in the yellow cube. They would technically see me right there, you know, my consciousness is right there in the moment thinking about it, but then they can see how I'm going to go in the future, and they're going to go ahead and see how I react in the past. And I know that's a really complicated concept to understand, but when you really analyze it, you realize that we would look something like this. A goldfish. Now, when you're looking at this goldfish here, just to put more dimensions to it, I'm going to say all these goldfish is basically you and I. And then what happens is we're going to the forward, and then there is a past. But what happens is when a fourth dimensional person is looking at us, we don't look like one thing. We actually have an energy body that's connecting all of us, like this green line. Obviously, the green line will go ahead into the future and go into the back, but basically from the beginning to the end, we have like this concept of a green line going through us that's connecting to us. So even though we may seem separated based on the film that we have, when you look at the bigger picture, we would probably look like an elongated snake form, and therefore all those snake forms are connecting to each other. But we don't realize it because we're kind of chopped up in time, and we only feel like that my past and my future doesn't really have a connection to each other. But this is how they would look like. So they can see, oh, I can see what you did in the past, and I can kind of see what you're doing in the future, and I can kind of see this long connection between all your past and future. And that's why when they talk about the fourth dimension, they say it's more a concept of time, because with time, you can kind of see the past and the future. In reality, we don't look separated as like a box or as a dot. We look more like a concept of a long line. Now, I know that's going to be kind of hard to accept, especially because we're third dimensional. But let me go ahead and give you how we would give you another analogy from the opposite end. So here you see an apple. So as you can see with this apple, you see it has width, height, and it has width, height, length, and then you can see that there's a width to the apple, which is dimensions. But how would this apple appear on the second dimension? So when you realize that, we have to kind of like look at the concept of chopping the apples up, because what happens is as you press down this third dimensional concept into pieces of paper, it's not going to have width to it. It's just going to be width and height, which would just come through in like little chops of pieces of paper. So technically, if there was a flat land of, let's just say, pieces of paper or something on two-dimensional, and here's how the apple looks like on a third dimension, but we can see it. As you were to press this, or if this third-dimensional apple was to visit a two-dimensional space, all the two-dimensional space would see is just a whole bunch of circles. So they'll just see the circle getting small, big, 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 and then small, and then probably see some green at the end because those are the leaves. Now, when you look at that, you would be like, wow, a circle visited me. But really what that circle is actually an apple. And the apple would kind of look similar to an orange. The only thing would be difference is color. A sphere would look something like this. Now, if they were intelligent and they try to hypothesize how we try to hypothesize about the fourth dimension, this is how they would hypothesize on the bottom, where they kind of look like they're stacked up on each other. It says how the second dimension would understand the 3D in theory. So they wouldn't really see how it looks like in 3D, but what they would do is they would try to take these little circles, stack them up on each other, and say, technically, if you just imagine that there was an even flow between all this, this is how the second dimension looks. And that is how they would perceive it. So you can see, like, from the dimensions, even from the third dimension, we can see clearly that it's an apple based on its width, height, and length. But on the 2D dimensions, they would just see it as a big circle coming in and a big circle coming out. Now, to go ahead and illustrate this further, this point a little bit further, I have here a concept of someone's which we should call their hands. And what they have here is, let's just say you were to put someone's hand on a piece of paper where the two-dimensional beings are. If you put your fingers there and not your palm, they would see you as, let's see, 1, 2, 3, 4, 5 dots. And technically those four dots or 5 dots are all connected to the one being, because you haven't pushed down all of your compression of your hand or actually pushed your whole face. They don't understand that you're much bigger than those dots. So technically they can theorize that either one, you haven't pushed your whole body in, so they can think that you're as big as the dots but you're not showing yourself. Or they can conceptualize that there's actually 1, 2, 3, 4, 5 different beings visiting them from the third dimension. So when you realize that, you realize the perception from dimensions can be vastly different than their perception, because they can't really perceive the dimensions. Because even if you were to tell someone on the second dimension, those are just 5 fingerprints of someone on the third dimension, they won't really understand that unless you try to push your whole body through. And even that would be like, what the heck is this? Because they would have to like take the slices of the impressions and try to line them up. And that would be a very an interesting feat to do, nevertheless. So when you realize that this whole concept of the third dimension is interesting, and that's why when you understand they see us as time, they don't really just see the separation, they see the connection, they see how everything's connected. But then the question comes in, is time really the fourth dimension? We're not sure yet based on physics. Well, the fourth dimension is not like the first, second, and third dimension, which is associated with space. Because remember, the first, second, and third dimension was associated with length, width, and height. But the fourth dimension is now dealing with time, and realize that time is something we really don't understand yet. So when they say the fourth dimension is time, that's more trying to conceptualize on a third dimensional perception the concept of being able to look at that wavily length or energy of snake form that we can actually look like on the fourth dimension. That's connecting. And what happens is, says the more we learn about space-time and general relativity, gravity, quantum entanglement, and M theory, is hard to accept that the fourth dimension is time. Not saying there is such thing, but we just haven't fully understood time yet. So yeah, we're now in a third dimensional perception, because remember, now we're acting like the second dimensional beings. We're trying to theorize or understand the fourth dimension on a third dimensional perception. So when you realize that, we said we understand the concept of time. However, time may be different from the fourth dimension, because if they can see us like a snake, that means they should also be able to see multitudes. But then you have to realize that, he says time as we know it, or how we define it, is an illusion, but it's based on a third dimensional perception. So technically, how our past and our future seems all separated is also illusion. But technically, if you see it from a fourth dimension, or if you saw it, you would see that we're all connected. But right now, because we don't have the perception to understand that connectionness of this one elongated representation of ourselves, it all seems like we're all separated like a movie film. So until you can understand that time is not an illusion, and as long as you're in the third dimension and you're working and you're aging, then time is definitely not an illusion. It's something that's real. So I have here, the circle is a symbol of infinite, where the end is in the beginning and the beginning is the end. The alchemists summed this up as the name Azoth, a secret substance, the hermetic or fluid light. The name Azoth is composed of the first and last letters in the three languages, A to Z in Latin, Alpha and Omega in Greek, and Aleph and Tev in Hebrew. So once you understand esotericism and things of that nature, you'll understand that sometimes you always talk about time is basically a circle. And what it is basically a concept of just keep going in a routine, and therefore sometimes you can look at time as an infinity. And also, when you're dealing with time, we have to realize too that time, we always right now can look at it going forward, but for the most part people don't understand how to go backwards. So because we only understand time going linear, then we don't really understand time, because when you think of the concept of, like, let's just say, when you're dealing with the concept of, let's just say, space-time, you understand that basically space is kind of like, based on Einstein, space is kind of like a blanket. And if you put something on that space-time, it can make that blanket seem heavier based on the gravitational pull, and therefore if something is flying past a planet that has a long gravitational pull or a heavy mass to it, it can slow down anything flying by it. So therefore, if something is flying on the blanket that's next to a heavy planet like Jupiter versus flying something like Earth, it can affect the time that someone travels to a destination. And also, when you think of things like the Big Bang Theory, you must realize that if there was a Big Bang and everything started expanding from the Big Bang, that means out in space, because there's no gravity, everything would have to go at a constant speed until it hit something else. And that constant speed at the same rate continuously would be what they call inertia. And inertia just keeps going, and keeps going, and not stopping. So if time is a concept that just keeps moving based on inertia, that means everything should be constant. But if you understand quantum physics and things of that nature, they kind of basically got to the concept of understanding that the accelerating universe is the observation. Well, basically this concept of the accelerating universe, which is the observation that the universe appears to be expanding at an increasing rate. So if the universe is starting to accelerate as opposed to just being constant, then you know that there's definitely something happening with the whole shape of the universe. Now this is going beyond our perception, because realize that if there is a Big Bang Theory, that means if something was to explode, it would finally hit a rhythm and will just go at inertia, which is consistently going at one speed until it hits something. But because I realize the universe is starting to accelerate, then there has to be an interesting shape to the universe where there's curvatures to make it accelerate. So that's when you have things like the donut hole theory of the universe. The donut hole theory of the universe is basically a description of the shape of the universe would be, let's just say, in the third dimensional torus. And basically this is how it looks like. So they're saying basically, you know, we're used to this whole one thing, but we think it's a curvature to it. So therefore when the universe goes to a certain curvature, it starts to accelerate. And that's why there's non-inertia. So it's kind of like a bubble within a bubble, if that makes sense. So it will look something like this. And then that kind of goes to the concept with infinite. If the universe is infinite, that means everything would never die out. So here I have a picture of a star. And here's the star system, and here's all the planets and all the stars. If everything is infinite, that means every single star that ever existed would infinitely basically light up. That every star, every planet, because it could infinitely glow and grow at a constant rate. And that means our night sky should be a lot more brighter than this, because every star would be infinite, every planet would be infinite. That means every light that was ever in the sky should be infinitely shining bright and never existing, because if it stops, that means it's finite, and the whole sky should be lit up like almost like daylight. But because we see stars burn out, and because we see that planetaries and black holes and things expire, that means we know that things are finite. So when things are finite, then we know that definitely there has to be, our universe has to be kind of finite in the same way. That means we know that our sun will end, and then therefore everything is only limited in experience. So when you understand that, then you know that time is infinite. It's finite as well to a certain extent. Now to go into this concept of those who understand, here is basically an article talking about the universe has finite lifespans based on the Higgs-Boson calculations, and this is basically what they suggest. So if you know that time is not linear and the universe is finite, then we don't really understand time, because that basically says time has an expiration date. So when we understand that then if we were to base the fourth dimension strictly on time, that means fourth dimension will cease to exist, and everything below or up it will basically not be able to be built up on each other, because usually these have to be foundations that build up on each other. So that definitely gives us something to think about and reanalyzing what we think the fourth dimension is. I heard the concept that the fourth dimension is not really time, but it just looks at the durations or the connectionness to the third dimension. So it's more like durations. It can look at the past and the duration of the future, but then you have to look at this as, how would you explain that in the multi-universe? Now, before I go to the multi-universe, you guys have to understand that too, when you're dealing with quantum mechanics, you're also dealing with quantum entanglement. And basically when you're talking about entanglements, you're talking about how something in the future or the past could affect something that doesn't seem like it's related. Now realize this will also validate the concept that we're more on the fourth dimension, where we look like more like wavy lines that's connecting our past, our future, and it's also going to connect us to alternative futures in a different universe, or something that's separated from us. Now we can't understand that, because from a third dimensional perception we just see like time capsules of the moments like flashing before our eyes. But on a fourth dimensional perception, they should be able to see our elongated bodies and the experience we choose to decide, the elongated body of the dimensions that we decided not to see. So they can see all these perceptions or potentials we had and how we chose to go through it. But when you understand the concept of entanglement, you would understand that entanglement basically means you can make change to photons in one point in space and time, and it can affect something on a total different level of a space and time. And though this is interesting to understand, is because it could say that time is not, time is basically relative to the present moment. That means I can change something in my present moment and affect something in time and space in a totally different, unrelated concept. But then this will also validate the concept of Kabbalion, as above, so below. So even though I affect something down here that doesn't seem like it has no connection to this upper world, it definitely has there could be an entanglement between the lower and the upper worlds based on the decisions that we have here. you can also compare this to the butterfly effect, where just something like a flap of a butterfly could create a tornado somewhere else based on the connectedness of it all. But I think what happens is when you understand that, you would understand more that there is a connection to everything, but we don't see it because we're living in this slip of time space where everything seems separated. But on the fourth dimension, and maybe in the higher dimensions of fifth dimensions, they see everything as lines of freeways connecting. Kind of like when you're on the freeway, you don't realize that there's these little lines connecting to everything, but when you look on top, you can see like the veins, or even our human body. Like when you think of our veins, a cell probably doesn't think it's connected to a stream of blood vessels, but when you look at it from the upper world, you can see that there's like strings of blood vessels, right? So that's basically how it is. But when you understand that the concept of quantum entanglement is actually a concept where you can affect things from different space and time, then you realize that the fourth dimension is something that we still have to analyze in regards to I'm saying it's just time. Here's a quick article where they basically did their first quantum entanglement photons through space and time. It's a real good article if you guys are interested in that. So, I kind of talked also about there's different types of worlds out there, and that's when you get into the many worlds interpretation. And it's basically something that you deal with quantum mechanics, and it's just basically talking about how we can have multiple different realities out there, and that these realities, even though we didn't choose to choose them, that they're still out there. So in essence, look at it as like we're in one of these boxes here on a film strip, and because we're in third dimension, we can only experience a box at a time. But on the fourth dimension and higher, they would probably see one strip would kind of be like your whole body through the life you chose to choose based on your consciousness. But then there's all these different type of parallel lives that you can actually jump into, or your body can actually break off into. So when you realize that, yeah, there is us, we're stuck in one cube of a third dimensional reality that's connected to the future and the past, but at the same time there's parallel ones that connects to it. So it would probably look something like this. So here I highlighted a red cube, which is something that we kind of experience right now, but in reality our bodies is like these long sliverly snakes, or just this long line of past, future, and present, which the fourth dimension can see. But then there's all multitudes of graphs, and then this is when it starts to get into the concept of sacred geometry. So when you realize that, we are just like the second perception. We are caught up in the illusion of time and the fourth dimension. So it's really hard to perceive the fourth dimension, but if you see the things from fourth dimension, you can see things through a snaky, wavy line that connects everything. So I have here, many parallel universes are part of the quantum wave function where we are currently in, based on the different choices in the multiverse. In other universes, for example, we could have not been alive, could have passed. Some believe that these dimensional outcomes are actually fifth dimensional twists and turns, and actually are just as real as our dimensional perception of observer. Some people even believe that the string theory is a connection of the third and the seventh dimension. Also, when I say the fourth and fifth dimension, people can say there's like we're working on here in this film, and then there could be people on the fourth or fifth dimension trying to help us or manipulate us, depending on perception you want to see it. But even if they could see our bodies from the past and future of this connectionness of this long snake-like feel, they could also see through us, so they can actually see our dimension or our thoughts. Was creating us to go one way, was to create us to go in a different way. So when you realize that it's a lot more complicated, and it's a lot more thought-provoking to see things from a fourth dimensional perception. And right now, because we're in the third dimensional perception, we kind of just see things, as basically third dimensional. But once to consider time an illusion to the concept of being that way, you kind of have to transcend the third dimension. And if at that time if the rules are still affecting you in the third dimension, then that means then we are part of the program, we're part of the illusion. And to see things from a fourth dimension is really to see things more vast. Just like a third dimension reality is so much different from a second dimensional reality. Just like the second dimension reality is so much different from the one dimensional reality. So like in the second dimension reality, they can actually draw houses. In the one dimensional, they can just only draw lines. So, you know what I mean? It's interesting to when you look at it from that perspective. But I kind of went into a lot of different concepts. I had other things I wanted to share, but that was my quick video about the fourth, first, second, and third dimension. I hope you guys liked it. I hope it made you guys see things from a different perspective, and I'll see you in my next video.